Section 8.4, Factoring Sums and Difference of Cubes and a General Factoring Strategy. There's a formula for factoring a sum of cubes. If you have two quantities cubed, a cubed plus b cubed, it's going to factor into a plus b times a squared minus ab plus b squared. You can factor a sum of cubes or a difference of cubes. The pattern for a difference of cubes is similar, but it starts off a minus b times a squared plus ab plus b squared. So they're very similar patterns. If it's a plus b, you start with a plus b. If it's a minus b, you start with a minus b. Let's look at example 1. X cubed is x cubed, and 27 is 3 cubed. That makes a x and b 3. This will factor then into x plus 3 times x squared minus 3x plus 3 squared, or plus 9. Okay. In part B, a is going to be a, since a cubed is a cubed, and b is going to be 5, since 5 cubed is 125. This one's a difference, so it's going to factor into a minus 5 times a squared plus 5a plus 5 squared, or 25. Let's look at the next two. In the first one, a is going to be whatever it takes to get 8x cubed when you cube it. So it's going to have to be 2x, since 2 cubed is 8. And therefore b is going to be 3y, since 3 cubed is 27. This is a difference. It's going to start with 2x minus 3y times a squared. So it's going to be 2 times 2 is 4, x times x is x squared, plus a times b, so 6xy, plus b squared, so plus 9y squared. In part D, a is going to be whatever you need to cube to get n to the 9th. That's going to be n cubed, and b is going to be 4, since 4 cubed is 64. This is going to factor into n cubed minus 4 times n cubed squared, or n to the 6th, plus 4n cubed plus 4 squared is 16. Check out the next page. How to factor a polynomial. You always want to factor out the greatest common factor if possible. Then the remaining part depends on what the polynomial looks like. If there are two terms, you're either going to look for a difference of squares, a sum of cubes, or a difference of cubes. If there are 3 terms, it's going to depend on if the coefficient a is 1 or not. If the coefficient a is 1, use c, break it up. If it's not 1, you can use grouping by multiplying the first and last terms. Then check to see if any of your factors are factorable again. If they are, continue to factor, and if not, you're done. In example 2, we want to factor each of these right here. Okay. Example 2, we want to factor the following completely. In part A, I can notice that there is a GCF. 10, 22, and 24 are all divisible by 2, and you can take an x squared out of each of them. It's going to leave you with 5x squared plus 11x minus 12. Let's see if we can factor that further. To factor that further, multiply first and last. It's going to get you negative 60. Try to break down negative 60 to get 11. Negative 60 is 6 times 10. So if you did 10 minus 6, that would get you 4. That one doesn't work. Negative 60 is also 15 times negative 4, and 15 minus 4 is 11, so that pair does work. So I break down this trinomial to 5x squared plus 15x minus 4x minus 12. I'm going to factor it by grouping. The first group can have a 5 and an x taken out. That'll leave you with x plus 3. The second group can have a negative 4 taken out, and that will leave you with x plus 3. So my final answer is going to have the 2x squared that we took out at the beginning times the x plus 3 that's in common times the 5x minus 4. In part B, the greatest common factor is going to be 2 x squared and y. If you factor that out, you're going to be left with x cubed in the first term minus 64 y cubed in the second term. This is now a difference of cubes that can be factored further. The a value in this difference of cubes would be x, and the b value would be 4y, since 4 cubed is 64. So we're going to get x minus 4y times x squared plus 4xy plus 4 squared is 16, y squared. In part C, 24 and 54 can both be divided by 6. So we're going to have 6 times 4x squared minus 9y squared. This is binomial. It's a difference of two squares. We can continue factoring. It's going to factor into conjugates. So 6 times 2x plus 3y and 2x minus 3y. In part D, trinomial with nothing in common. So we're going to multiply first and last. That's going to give us 12. Looking for two positives here. So I can use 3 and 4. 3 plus 4 is 7. That doesn't work. We could also use 6 and 2. 6 plus 2 is 8. Or 12 and 1. 12 plus 1 is 13. There's no other way to multiply to a 12, so this polynomial is prime. It cannot be factored. Two terms. Let's start by writing this in descending order. It's going to be 3x to the 4th plus 3x. Now we'll factor out the greatest common factor. I can divide these both by negative 3x. So if I divide out negative 3x, I'm left with x cubed minus 1. X cubed minus 1 is a difference of cubes. So to continue factoring, I have 3x times x minus 1 times x squared plus 1x plus 1 squared is 1. In part F, I also need to write this in the correct order. So it'll be negative 27y cubed plus 8. I can factor out nothing but the negative, but we'll go ahead and factor that out. Negative 27y cubed minus 8. It's another difference of cubes here. So I have negative 3y minus 2, since 3 cubed is 27 and 2 cubed is 8, times 3 squared is 9, y squared, plus 3 times 2 is 6y, plus 2 squared is 4. Example 3, we're going to factor completely. Part A has 4 terms, so the only way to factor it is by grouping. If I factor that by grouping, I can take out an x squared and be left with x plus 5. The second two terms can both be divided by negative 9. If you divide out negative 9, you're left with x plus 5. X plus 5 is in common, so you're going to have x plus 5 times x squared minus 9. Now this is not yet completely factored, since x squared minus 9 is a difference of squares. So we're going to have x plus 5 times x plus 3 times x minus 3. A difference of squares will factor into binomial conjugates. Part B, this is a sum of cubes. The a in the formula is going to be 4c, since 4 cubed is 64. And the b in the formula is going to be 10, since 10 cubed is 1,000. So we're going to factor this into 4c plus 10 times 4 squared is 16, c squared, minus 4 times 10 is 40, c plus 10 squared is 100. The next one, we've got a trinomial with coefficient not 1, so we're going to multiply. 8 times negative 10 is negative 80. Let's break this down. If I do 10 minus 8, I get 2. That doesn't work. If I try 20 and 4, I get 16, so that doesn't work. 5 goes into 80 16 times, so if I try 16 and 5, that gives us 11, so that one does work. Let's set this up to factor by grouping. 8n squared plus 16n minus 5n minus 10. Let's group. Factor out 8n, you're left with n plus 2. Factor out negative 5, you're left with n plus 2. So your end result is going to be n plus 2 times 8n minus 5. In part D, 4w squared, 20wz, and 36z squared can all be divided by 4, so we're going to factor that out first. Be 4 times w squared minus 5wz plus 9z squared. Now, since the coefficient of w squared is 1, I can use 1 times 9 is just 9. Let's break down our 9. I need two negatives to add up to negative 5. 9 could be negative 3 minus 3, which is negative 6. Or negative 1 minus 9 is negative 10. There's no other way to make a 9. None of these work, so it was fully factored by just taking the 4 out. So that's my final answer. I can't factor that further. In part E, 14, 21, and 7 can all be divided by 7. So we're going to take out 7, A, and B. We're going to be left with 2 times A times B minus 3 times B plus 1. This is no longer quadratic, so I know this can't be factored any further, so this one's done. And part F, 16a squared minus 40ab plus 25b squared. Let's go ahead and start factoring this. I'm going to go by trial and error. 16 can be written as 4 times 4. So I have 4a in the beginning of each parenthesis. And 25 can be written as 5 times 5. So I'll have 5 in the end of each parenthesis. I know that if I want to multiply to a positive, I need two positives or two negatives. So they're going to have to both be negative. Let's check. 5 times 4 is negative 20 AB. And 5 times 4 is negative 20 AB. That adds up to negative 40 AB. So I have found the correct answer.